Good afternoon, all. And, in this lecture, we will discuss about the Ohm's law and the resistance. So, first of all, we cover the Ohm's law. We will cover the Ohm's law in this lecture. So, you can see here in the right hand side. You can see here the picture of a scientist George Simon Ohm. Picture of a scientist George Simon Ohm. The Ohm's law is given by the same scientist. So it was stated by the George Simeon Ohm, and the statement of the Ohm's law is that it states that at constant physical condition, kindly noted that point, the constant physical condition like temperature are kept constant, then the amount of current flowing through a conductor is directly proportional to the potential difference across its edge. That means at a given constant physical condition like temperature, pressure, so the amount of current flowing in a conductor, that amount of current flowing through a conductor is directly proportional to the potential difference across its end. You can say the voltage in this conductor. So the I is directly proportional to V, and when we remove the proportionality sign, then we use a proportionality constant 1 by R. We use a proportionality constant 1 by R, and by this derivation, consequences that derivation V equals to IR, and where R is constant, and R is also called a resistance. Where R is a constant, which is called resistance. So George Simonov gives a Ohm's law, and Ohm's law states that at a constant physical condition, the amount of current flowing through a conductor is directly proportional to the potential difference across it. So the I is directly proportional to V, and this proportionality constant is removed by using the 1 by R, and that finally we get the V equals to IR, and the R is a constant here, and which is called resistance. So the according to this law, conductors are divided into ohmic conductor and the non-ohmic conductor. And the ohmic conductors are those conductors which follow the Ohm's law, which follow the linearity of Ohm's law. And non-ohmic conductors are those conductors which do not follow the Ohm's law. So you can see in the next slide that there are two pictures. In the first picture, you can see the ohmic conductor which follow the Ohm's law. That means if the voltage increase, the current increase rapidly or linearly. You can say rapidly or linearly. In the second picture, you can see the voltage. If the voltage increases and the current not increases by a straight line, it follows this path. So it's a non-ohmic conductor, and in the ohmic conductor, the voltage and current are proportional to each other. So it follows a straight line equation, and this do not follow the straight line equation. That's why it's called a non-ohmic conductor, or that do not follow the Ohm's law. So these are the IV graphs for the conductors, which are the ohmic and non-ohmic properties. So in the next slide, we will discuss about the resistance and the resistivity. The resistance and the resistivity. So, by the Ohm's law, you can understand there is a constant R, and which is called the resistance. And the resistivity is a property of any conductor, any metal. So, we can define the resistance, and the resistance is defined as the hindrance to the flow of currents. You can say it's a barricades, it's a barrier in the path of current. You can say in the barrier of the path of current, in the flow of current. So it is given by the ratio of potential difference to the current, and the value of resistance is given by R equals to V by I. So it's the ratio of voltage to the current. So the SI unit is volt per ampere, and you can say the ohm, which is given by as the name of scientist George Simon Ohm, and symbolic representation is shown by this sign. So the reciprocal or resistance is called reciprocal of resistance. The reciprocal of resistance is called conductance. That means G. That is G. So G equals to there here. G is the conductance. G equals to 1 by R. If resistance is minimum, then conductance is high. If resistance is high, then conductance is minimum. So conductance is always in the benefits of conductor. Is has the benefit side is the of the conductor. So the unit of ohm inverse. You can say the unit is ohm inverse. So high resistance, that means the low current flow through the circuit. Low resistance, that means the high current flow through the circuit. So if we want to control the current, then we can use the variable resistance. So by using the variable resistance, or you can say the rheostat, we can control the value of current. So the current can be controlled by using the value of resistance. You can say the value of resistance. So now we will discuss about the factor affecting the value of resistance. So the first equation show that the R proportional to the length, R proportional to the length L. This is the L, length L. So R proportional to the 1 by area of cross section of conductor. So you can say the length of the conductor is directly proportional to the R. Or you can say the area of cross section of conductor is inversely proportional to the R. That means resistance. So if we follow the equation number 1 and equation number 2, then we get R equals to L by A. R equals to L by A, length upon area. So this proportionality constant. So let's see here. R proportional to L, length, by A, area. So when we mitigate this proportionality sign, when we remove this proportionality sign, then R equals to, we use a constant rho L by A. So we got this equation R equals to rho L by A. So this is given by here R equals to rho L by A, where constant rho is the specific resistance of the conductor. So here rho represent the specific resistance of the conductor. So you can also see in the diagram there is a length L, there is a cross section area A. So this area is inversely proportional to the R, and this length is directly proportional to the R. So rho is here the resistivity of any material. So rho is called the specific resistance. So now we will talking about the specific resistance. The specific resistance rho is the resistance of a conductor of unit length and unit cross sectional area. That means if L equals to 1 meter and area equals to 1 meter square, then R equals to rho. then R equals to rho, that resistance is equal to the specific resistance. At the given condition, when L equals to length of the conductor is 1 meter, that unit length and unit area, you can say the unit area 1 meter square, A is equals to 1 meter square, then resistance of the conductor is equal to the specific resistance of the conductor, and R equals to rho. So rho is always depend upon the material of the conductor. The value of rho is depend upon the material of the conductor and denoted by the rho, and this is the sign, and the SI unit is given by ohm meter, and that is represented by the ohm meter, and this rho is proportional to the temperature of the conductor, and also known as resistivity. It's also known as resistivity. Then this rho is depend upon the temperature of the conductor. So if we increase the conductor, then the resistivity is also increased. So this is the resistivity table, which is vary according to the material of the conductor, that like silver, copper, gold, aluminum, tungsten, iron, steel, platinum, lead. So the resistivity at 23 degrees Celsius, that is given in the ohm meter, and again the nichrome, poles, aluminum, silicon, and glass, rubber, sulfur, quartz. So there are many materials, and along with their resistivity at the 23 degrees Celsius. So you can see here the resistivity, the varying resistivity, uh, which is vary according to the material of conductor. So thank you so much for your kind attention. If you have any query regarding the same, so you can ask me, and thank you again.